Lesson 2, Probabilistic Neural Networks. To follow along with this lesson, you should be familiar with multivariate functions. In a probabilistic neural network, we construct a classification function. We begin with a training set of classified data points like these. The different colors represent different categories or classifications. For this lesson, we will create a neural network to perform optical character recognition, or OCR. And we will use the network to distinguish between the letters O, X, and I. Here we have a set of 7 letters to train on. Our input parameters will be the length and area of the characters and will be scaled to fit in the intervals 0 to 1. I just made up these parameters for illustration, so don't take them too seriously. Each trained data point corresponds to a pattern unit, which is just a Gaussian function with a peak centered on the parameter's location. For example, if the parameters are x0 and y0, then the corresponding Gaussian has this equation, where sigma is the constant that controls the width of the function. For this tutorial, we set sigma to 0.1. The pattern units for each category are summed to create a category unit. That's all there is to it, so there really is no training step on a probabilistic neural network. In this example, we add 2 O pattern units to get our O category unit. Next, to get our X category unit, we add our 2 X pattern units. Finally, these 3 I patterns are added to get the I category unit. Since the network does not require training, we could add new pattern units at any time without additional overhead. Our probabilistic neural network for OCR looks like this, with an input layer, pattern layer, and category layer. To see how it works, imagine that we have this imperfectly printed O character. To generate the classification of our character, we begin by putting the parameter values into our input units. Next, the input values are passed into the pattern units, and the responses for each pattern unit is calculated. All of these values are shown rounded to the nearest 100th, and most of the values are nearly 0. Then the pattern units for each category are summed in the category units to get the response in each category. Finally, we take the maximum response from the categories to get our classification, and our symbol is classified as an O. That covers the classification algorithm for a trained neural network, and training the network is automatic. Just add new data points to the appropriate category set. The pseudocode for the classification looks like this. We begin with a point X that we want to classify. The final class index or category index will be stored in max class, so we initialize it to -1. The max response will be the largest response from the category functions. We loop over the classes or categories and sum over the patterns in each category. We check and update the max response and max class for each class. This concludes the lesson.